Okay, we're going to start day 4, and this is the graphing of sine and cosine functions. So if you don't mind, let's take a moment. I want you to fill this guy out. You can use your unit circle if you want to. Maybe try to quiz yourself every now and then, but do for the cosine, we're going to do the exact value. So for instance, 0 degrees is the same thing as 0 radians. And the cosine for 0 is 1, and the exact value, the exact is 1 and the decimal is 1. And then the exact value here would be radical 3 over 2. The decimal for that, type in the calculator, 0.866. So go ahead and fill this out. Fill this out for me, and then continue your video. Okay, so now you have filled out. Just one thing to look at, kind of look at the symmetry of this. There's a lot of places you can pick a point, and then, like say here in the middle, work your way out, and it's symmetrical. Or you could pick a point here and work your way out, and it's pretty symmetrical, except one's positive, one's negative. And over here, same thing. Positive, negative, positive, negative, positive, negative. There's a lot of symmetry here, and that's kind of part of it being a periodic function. It's a sinusoidal curve. It keeps repeating itself. So now, down below here, I want you to plot these points. So just take a second and plot all these points on the graph. So like cosine of 0. So here's 0. That would put you at 1. And let's just say, to make us kind of blow this up, let's make this 1 and this -1 here. So these are quarter steps here, and that might help you estimate where your points are. So cosine of 0 would be 1. And if I go to pi over 6, well, that's the same thing as 30. And these are each 30. So at 30, I'm at about 0.866, so a little bit more than 3/4 of the way up. And then at 60, I'd be at a half, and so on. So go ahead and finish this. In fact, you can probably just do both of them. I'm actually just going to do one because it's going to be the same thing. It doesn't matter if you're doing degrees or radians, the picture's going to look the same. So I'm just going to do this one. You can kind of think of it the same way as it's just repeating itself. But plot all these points down here, and you should get something like this. And hopefully I didn't go too fast for you. If I did, just pause and come back to this. And it is a curve now. It's not a V shape. It is a curve. So it's kind of flat up here, and then it starts to dive down. Its steepest slope is here at the 90. So diving down, and then it's going to level off, come back up, and level off again. So it looks something like that. And this is a cosine curve. Now it's going to keep repeating itself. You just take a picture of this and copy and paste, and you'll get the whole thing going both directions too. Now the domain of this guy, this thing goes on forever. Okay, and if you were to put this in your calculator or put it into Desmos, it just keeps going on forever. So the domain, you can type in anything. So this is -infinity to infinity. The range for this, now range means y's, for this parent cosine function, it's going from -1 to 1, where -1's included and 1 is included. The maximum is 1, the minimum is -1. The symmetries here on this guy, if you kept going in both directions, this actually is symmetrical about the y-axis. So this is about the y-axis, and if you remember, when it's symmetrical about the y-axis, that means it's an even function. Okay, so it's an even function. On this one, a period. What's a period? How often does it repeat itself? It goes through, comes back up, and it hits there again. So it's 360 degrees, 360 degrees, and then which is also 2 pi, because had I graphed it down here, it makes the exact same shape. Now the x-intercepts, or the zeros, are going to happen, you could say when x equals, and it depends on whether we're talking about degrees, like the first one's at 90 up here, the first one's at pi over 2 down here, and then you could just cycle through that, but it's not every 2 pi that it happens, it's actually every pi that it happens. It goes down, hits it, comes up, hits it, goes, and it's going to every 90 degrees, it's going to, every 180 degrees it's going to hit it. So 90 to 270, that's 180 degrees. So instead of being 360 at the period, the x-intercepts happen every 180 degrees. So I'll say n as long as n is in those integers, and then or this would be plus pi n, so pi over 2 plus pi n. So that's how the cosine function looks. Okay, so let's flip this guy over, and we'll do the same thing with the sine function. So if you don't mind, pause your video and just fill these in. That way I don't want to spend the whole video me writing, so I'm going to pause my video and fill these in. keep in mind you're doing sine now instead of cosine. Okay, and once you get this filled in, again, a lot of symmetry here. So if I start here and work my way out, same values. If I start here and work my way out, same values but opposites. Start here, same values. So there's a lot of symmetry involved, and that's all about the periodic ness. I don't know if that's a word or not. The periodicness of this kind of function. So now, take a moment, same thing. Plot those on the graph down there. So plot these points. Again, I'm just going to do the top graph because the top and bottom will look the same. But go ahead and plot those. And again, make this 1 and -1. Okay, and that way our graphs all kind of look the same. So like sine of 0 is 0. So the sine function always comes up through 0. Remember, cosine started at 1. Sine's going to come up through 0. At 30, it's about a half, and so on. So plot the rest of those points. And when you're done, it should look like this, and it looks an awful lot like a cosine, except it's just shifted over a little bit. Connect these dots, make it a nice smooth curve if you can. And let's answer all the stuff about this. So domain, same thing. This just keeps going forever in both directions. So negative infinity to infinity. The range, again, the highest it ever gets is 1. The lowest it ever gets is -1. They're actually included because they're down here. They're in the domain. Those numbers are in there. The max is 1. The min is -1. Now this guy, the symmetry on this, if you remember, if I flip this over, I won't get a sine function. So I can't, it's not about the y-axis. They're actually both symmetrical about the x-axis. I should have put that, but because if you flip them over, you get the same thing. Actually, no, you won't get the same thing. I'm sorry. Forget I just said that. Because you can flip them over, but it's a negative, so it isn't the same thing. So they're not symmetrical about the x-axis. But this one is actually, if I rotated 180 degrees, I would get the exact same graph. So this one is about the origin. This one is about the origin. If you remember, origin means odd. Origin, odd. They both start with O. A period on this one. To get back, now, some people might think, well, you're back at 0 here at 180, so it must be 180. But after that, you got new values. So it's from here. This is a period. So from 0 to 360, so 360 degrees or 2 pi. And then the x-intercepts on this, you could say that the x equals, the first one's at 0, so I'll just say 0, 0 plus, or we don't need to put the 0. So it's every 180 degrees you get a 0. So 0, 180 later, 180 later. So every 180 degrees, so at any 180 times n, and if I plug 0 in for n, there's my first one is 0. As long as n is in the integers, or every pi. Okay, so pi times 0, pi times 1, pi times 2, those are going to be the zeros of that. Okay, so if I want to graph this, or do some graphs with these, we want to do some transformations now. So just knowing what the shape is, let's do some transformations. And we're only going to deal with, on this one, we're going to do vertical stretch and shrink and horizontal stretch and shrink. There's a lot more we can do with it. And we'll do, there's a third day we'll get with this, or actually a second and a third day we'll get with this graphing. But one of the things here, so I've multiplied by 2. One of the things I want to talk about here is amplitude. Okay, the amplitude is the height from the midline, so where the middle of it is, where the middle of the graph is, so the horizontal line through the middle of the graph, to the peak or to the valley, so how tall it ever gets. So on these other graphs we just did, like this guy, the midline would be the x-axis. Okay, so it's a high, low, and the altitude was 1. So basically the altitude for the parent function is a 1, and then the only way to change that would be to multiply something out front. Like this a value here, if I have a 2, that changes the amplitude. And it is the absolute value of a, because if you had a negative on this, it would still, like if I had a -2, the amplitude is still 2. So this graph has a vertical stretch. Putting a 2 out front like that is going to stretch things out. Okay, it's going to be a vertical stretch of a factor of 2, and it has an amplitude of 2. I'm sorry, of 1. I'm sorry. No. This amplitude is 2, the original one. So this is a factor of 2, which means that's also the amplitude. And this, so the vertical stretch and the amplitude are kind of the same thing. So if you see the word amplitude, that's what they're talking about. So the original sine function, and so I can fit both these in the graph, I'm going to go 1, 2, -1, -2. The original sine function, remember, sine starts at 0, and then it's going to repeat every pi, so it has zeros like that. About halfway through, it's going to be up at 1. It's going to look like this. So it's going to just maybe I'll do a dotted here. So that's sine of theta. 2 sine of theta would be this. All of these points get doubled, but these stay 0 because 0 times 2 is 0. This one, so it's a vertical stretch. So this one's going to be higher, go through the same 0, and then lower than the original graph. So that's what the amplitude change does there. Okay. Now this cosine, I got 1/2 out front. So just regular cosine, the amplitude's 1. Now the amplitude is 1/2. So this is actually a vertical shrink of a factor of 1/2. So the original cosine, and maybe I'll do this, I'll say this is 1, this is -1, and then this would be 1/2, and this would be -1/2. So the original cosine starts at 1, up at 1. It's going to come down like this, and make a graph like that. So I'll just do a dotted line for this. That curve got a little whopper job there. Okay, looks something like that. Now to have an amplitude of 1/2 now, all these points are halfway away from the x-axis. So now this is going to look something like this. Okay, so that would be the 1/2 cosine theta. If a happens to be less than 1, so if it's negative, it actually flips it over. So on this guy, if I have a -1/2, well, if I do the original, I'll say this is 1, -1, 1/2, -1/2. The original sine function goes through 0, goes up to 1, comes down to pi. So it's like this. So I'll just do a dotted line for this. So that's sine of theta. Now -1/2 actually flips it over, and the amplitude is 1/2 now. So this point gets flipped over and then cut in half. This point gets flipped over and then cut in half. Now it's still going to go through these zeros. Zeros don't change on this one when you're doing amplitude change. So this is actually going to look something like this. Okay, so there, that would be the -1/2. So amplitude, if it's negative, it does do a reflection about the x-axis. And then if it's a number, then it's going to stretch or shrink it. So this one has it's a reflection about the x-axis and a vertical shrink of 1/2. Now horizontally, and what that does is, and if right now we'll just keep it simple, we'll say it changes the period. Okay, so it happens if the vertical stretch, if it stretches it, then it's going to move slower, which means the period is longer. If it is shrink, that means the period's faster. Something's happening more often, more quickly. And that is the number that's in front of theta. So if you put a number in front of theta, you're going to change how quickly it repeats, which is going to stretch it or shrink it horizontally. And kind of the period is going to be 2 pi over b, whatever that b is. So on this one, if it's a 2 pi over 2 means now, instead of having a period of pi, or 2 pi, now has a period of pi. So sine originally started at 0, went up, went down, and repeated itself at 2 pi. So I'll just say this is 1, and this is -1. So here's normal old pi, or normal old sine. Here's what sine looks like. But now, if it repeats itself every 2, that means it has to go up, come back down, and then go through it here. So it's going to be cut in half. It's going to go like this. Oops, going to be more here and here. So it's going to go like that. It did one, this is a frequency, so 1 period, and then it's going to go up again. So see how it does 2 cycles in the time that sine does 1 cycle. So that would be a horizontal shrink. So this is a horizontal shrink of 1/2. So everything got shrinked half of what it was. So it was here, we squished it into half. Everything that happened here is going to happen in half amount of time. This guy here, we had two things going on. So we've got this 1/2 in here, so 2 pi. And if you notice, this was a 2 and that was a shrink. It's kind of the opposite of what you think. So having a 1/2 here, you would think, oh, that's going to shrink it. No, it's actually going to stretch it. When I divide by 2 pi, that actually becomes 4 pi as a period. So it's going to take 4 pi to do a full cycle. So this here is a horizontal, and this would be a stretch. Okay, horizontal stretch of 2. And then this 2 right here gives you a vertical stretch of 2. Okay, so if I just do my normal old cosine, and I'm going to make this 1, 2, -1, -2. Normal old cosine starts here, and comes down here, looks something like this. So now, but instead the amplitude gets doubled, so now this is going to be up here. And the lows are going to be twice as low, but it's going to happen slower. Okay, so instead of doing one full period here, everything gets doubled. So instead of this point being here, now it's there. So it's going to come down here. And instead of that bottom happening at pi, it's going to happen at 2 pi. So you really only see it, and then this one would actually come back up the other way. You know, it'd take twice as long to do a full period. So this is what where we have a combination of a vertical stretch and a horizontal stretch all in one. Okay, so yeah, let me know if you have any questions. Try the homework out. Hopefully this helps.